Aha, I know I asked group 36.
Okay, today I will discuss about or explain about the production of the dumbbell and the defect that occur during the manufacturing process of the dumbbell. So before that, I will introduce my team. Uh, we are from group 36 and my name is Daniela and Agustin. No, my metric number is 69440 and my partner is Azrin Hazin bin Azimi 69198. So as you can see this is those are the process of manufacturing of the dumbbell. So the first is designing a dumbbell, second is select the suitable raw material, third is dumbbell pattern making, then set casting, metal forming process, joining process, machining process, non-metal forming process, transfer molding, and lastly finishing. Okay, so firstly, the first process of the production is designing a dumbbell. Designing dumbbell helps to define and plan and produce the product, and the manufacturer can effective and transparent and focus on the creating the dumbbell so that it can reduce the cost and difficulty of producing a high quality. And second is selecting suitable raw material. In this case, for the dumbbell that we produce is we use pig iron and natural rubber. Pig iron is from cast iron, that molten iron, cast iron. Yes, they use pig iron because it's costless and it can withstand high dynamic load and of component, withstand pressure at low and or high temperature, and then it long lasting and high durable. That's why it uses pig iron. So third is making dumbbell pattern. Uh, as we know that the pattern is a copy of the product to be cast and then used to prepare the cavity of the model for the dumbbell weight and the handle of dumbbell. Before that, there's a few things to consider when making the dumbbell pattern. First is shape and core print supportive. And second is parting plate. Third is pattern dimension. And fourth is pattern material. It's important to choose the material because it will withstand the molten heat and minimize the defect. Set casting. Set casting is known as a set mounting casting. Is a casting based on manufacturing technique that emulate a set mount. Green set is used for this set casting, and set casting mostly used for this casting because for producing cast iron dumbbell, and it funnel the molten mold into the mold cavity using a pouring cup and turner or gate to the mold, and then the set assumes the form of the mold pattern as it is put in it. The molten cast iron then is poured into the set cavity. This the further a semi-automatic line is typically used in this process. After pouring, it must be allowed to cool for 6 hours to 8 hours. After as the molten metal cools, it will revert from a liquid state back to a solid state, which is the dumbbell weight and the grip of the dumbbell, which is the handle of the dumbbell. And then the fifth process is metal forming process that involves threading. Threading is the process of machining a screw or other fastener to produce additional threading, so that the handle of the grip and of the dumbbell can fit into the dumbbell weight more efficient to avoid the fail apart. Then joining process, it involves welding. For this production of dumbbell, nickel alloy electrolyte are used because it has lower coefficient of thermal expansion. The weldings or joining between the weight of the dumbbell and the handle of dumbbell. So joining. Machining process. Machining process is like milling, polishing, smoothing, grading, sealing, and so on. After the joining process for dumbbell. So this procedure is ensure the cast iron dumbbell consistency that it didn't affect the quality of the dumbbell. And then non-metal forming process, it involves rolling for natural rubber. It used because so that the ingredient in the rubber, natural rubber, are firmly dispersed throughout the rubber. And then the mixed rubber is then removed from the roller and transformed into pellet and shrimp, like this. This is rolling. The black is the natural rubber. After the rolling process, it will undergo transfer molding. Transfer molding is a process which is casting material forced into a mold. The anchored natural rubber are inserted into the heated wear pot of the transfer mold after the cast iron dumbbell are loaded. This is cast iron dumbbell and this is the natural rubber. And then the rubber is forced into a shroom in the wear pot and into mold cavity immediately under the wet pot of mold by a piston. This is the machine. Once the cavity have been filled, the mold is sealed under the pressure until the time it takes for natural rubber to cure. This process is normally takes 15 minutes, depending on the size of the weight, dumbbell weight, because the dumbbell weight has different size depending on the weight that want to produce. After the dumbbell cloth with the rubber, the next step is the finishing. After when undergo the transfer molding, there will be some flash occur because of some defect flash. Yeah, when this happen, the work, like this picture, the worker cut the flesh of the rubber dumbbell using a specific knife, so that is clean and safe to use it. So this is the final process for production of dumbbell. And then the defect that occur for dumbbell manufacturing, there's 4: misrun, co-sharp, shrinkage, and metal penetrate. Misrun is it happen when the molten metal pour into the cavity. It doesn't fully fill the cavity mold. And then co-sharp is a crack with a round agent on the casting surface. Shrinkage happen when dumbbell weight contract as it transitions from a liquid to a solid, and it contract even more as it cools to room temperature. Metal penetrate happen when the liquid metals seep into the hole in the molding set. So there's a way to prevent the defect. So for the misrun, like this is misrun. So to prevent the defect of like misrun is the fluidity of a molten case increase the molten temperature rise as the pouring temperature rise. Okay. The second is a good getting device, and the last is that is to think is avoid. So for co-sharp is optimize the getting mechanism to reduce error cross path to keep flow path short. This is a co-sharp defect of co-sharp. So second prevention is avoid premature solidification. Third is rise the pouring temperature. And fourth is improve the mold gas permeability. Okay, for the shrinkage is create a running mechanism with a razor to ensure the molten metal flow continuously. And second is insert internal shear, cooling ribs or cooling coil to increase local heat dissipation and reduce the casting temperature to keep the overall volume deficit to a minimum. And for last defect is metal penetrate. The way to prevent it is fix certain place to prevent metal intrusion. And then the second is set ramming with a high strength. And third is the limited grain size of the sand. This is a metal penetration. So that's all for me. Thank you. I will pass the next agenda to my partner Azrin. Okay, thank you. Ciao.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Azri Azim bin Azimin. I am from Group 36. My group did manufacturing on the item, the product, which is dumbbell. So, okay, I'll be doing the part D, which is identifying the design considerations involved in each of the selected manufacturing process respected to the product, which is the dumbbell. So, without further ado, we shall start. So, our first design consideration that is involved is the draft angle. So, what is the draft angle basically? So, a draft angle is the angle applied or allowed on all the vertical faces of a pattern that helps to aid and easen the removal from sand mold without damaging its wall. And also, the aspect of sand is of sand cast design is often overlooked, even though it is critical for casting process of the product. For this case, is the dumbbell. So we have to make sure that the suitable draft angle is used, because it helps to increase the castability and reduces the tooling cost, which is vital. And the angle required of the draft angle is basically depends on the molding process, what the process is, and the cast design, the design of the cast, the shape of the mold that is being used, and the pattern inside the mold, because that's going to determine the finishing of the product. So furthermore, is to reduce the other consideration in the design that we're gonna discuss is to reduce the thickness of the cross section. So basically, this part is taken place during rolling in the dumbbell process, which is the non-metal format, the non-metal forming process, which is to roll the rubber, which is gonna be used for the coating of the metal dumbbell, right? So the rolling process. So for most rolling process, its objective is basically to reduce the thickness, or to deter or change the cross section of a long workpiece. And by using the compressive force between the two rollers, the two two medium-sized rollers, that's gonna apply compressive force to the workpiece, which is in this case it's not metal, it's rubber. And and this is also where the edge conditioning comes vital, to avoid rounded or burr edge, to form rounded or burr free edge of the finished workpiece that has been undergo rolling process. So another aspect of consideration, the aspect of design consideration, which is crucial, which is machining on the sharp edges, the sharp features that exist or evolve on the dumbbell. So as you can see here, and as we all know, edges, corners, and points are mainly the common defects that forms on the product, and regardless of what the product, including dumbbells, is also formed normally after the materials undergo casting. This is particularly because the solidification it experiences, and also the solidification that it experiences influences the shape of the mold, which is, if the shape of the mold have a curvy and have a very sharp and pointy edge, then it's going to affect the product. So oftentimes sharp corners results in stress concentration of the workpiece, which is that excessive stress will cause fatigue, will result in stress concentration that will cause fatigue, thus reducing its quality. And also, this is why the pointed cutting tools comes in handy, comes in place, where it is required to remove the edgy sharp edges, as you can see here. And also, the best tool, the best tools that can use to remove the sharp edges, as I would suggest, is a die grinder with a mounted point, because this process that they use the die grinder with mounted point will round the edge of the metal here and create a groove at the point, and you just repeat and run the mounted point until the sharp edges are actually broken. So moving on, we have another one, which is to maintain a uniform mold thickness. Alright, this actually takes place during transfer molding, or it is well known as injection molding. So keeping all major sections throughout the part is as consistent as possible is crucial, because we don't want to form uneven surface. We want to maintain the quality, we want to maintain the surface, and it is shown that inconsistent wall thickness causes pressure spikes, metal degradation, too high of differential pressure across the part, and poor process control. Yeah, and also the plastic cools at different rates when you have varying wall pressure. For example, when you have a very high wall pressure, the for example, if you have a very high wall thickness, then it's gonna cool down. Then it's gonna take a long time to cool down, because less heat will be escaped out of the mold surface. And also, the mold surface actually cools outside towards inside, from inside out, and the middle of the part will cool at the last. So that's part D done, which is identify the design consideration of each selected manufacturing process. Now we shall move to part E, the last part, which is the optimization. Optimization, which is analyze how the selected manufacturing process with respect to the product can be optimized. So, okay. First is the type of sand involved in the sand casting process. Alright, so the breakdown of sand will often lead to the roughness of the casting, and essentially the breakdown of the sand will often lead to the roughness of the casting. And this is why the type of sand chosen is very vital, very crucial. And sand must be chosen carefully, as the size and the shape of the sand particles, the size of the shape of the sand particles influences the surface finishing on the final product of the dumbbell. So, the finer the particles, the better the surface finishing, as the finer particles produces better surface finishing. And it would suggest to mix the sand with the cold step binder and the catalyst, as this to create a strong and durable mold. Thus, in return, it helps to create an excellent surface texture of the casting of the dumbbell, a smoother texture rather than a roughy sandy surface. So, moving on to the next one, which is the right cutting tools. Right cutting tools is vital, especially during machining process, where it involves milling, turning, drilling, all are taken place during the manufacturing of the dumbbell. So, as I would suggest, carbide tools are a better option. Because the carbide tools have cutting speeds 4 times higher than the normal high-speed steel. And also, the carbide tools used are made of hard steel at high cutting speeds, and the coating of the steel is used. This is slightly because it helps to improve the tool's performance, that helps to withstand high temperature. Normally, because to high speed machining, that too much force will often cause the temperature to rise on the surface, and thus it will cause some tools to wear out easily, to become damaged. That's why it's important to apply coating, the right coating tools, and that's why right cutting tools is vital, because if you use the wrong one, then it's gonna affect the process involved, the machining process. So last but not least is use efficient material. This is a key tip for improving injection molding process and the final product quality. As I would suggest, is to try to reduce the short size, and this is because dropping the short size by minimum of the machine's maximum capacity will help the application nozzle to pull more color and work the check ring more carefully, and thus this action helps to make later cleanup easier and helps reduce waste material. So that's all from us, and I would like to say thank you and goodbye.